Hello students, welcome to my virtual classroom. We know that the class 12th physics exams are coming up very soon next month. So from today we are going to put up some videos about important topics that can come in these exams. Today we are doing with the force between two parallel current carrying conductors. So how do we derive this? When current flows through a conductor, it generates a magnetic field. So we have current I creating magnetic field B, because of which this particular wire, the second wire, experiences force which is given by BIL. This is the step or the flow which we are going to go. So we have two parallel wires infinitely long, separated by a distance r in air. For the first wire x1 y1, the magnetic field generated at, let us say, point P will be given by B1 is equal to mu naught by 4 pi into 2 I1 by R. This magnetic field direction can be found by right hand thumb rule. It goes like this. We can see that it is perpendicular in the inward direction. So we draw it something like this. This is my B1. So magnetic field is going inside the plane. Current is going like this. Therefore, the angle between vector B and current element I2L is equal to 90 degree. This is the angle between them. Therefore, the force experienced by the second wire due to current in the first wire, we call it F21, is equal to B1 I2. We are not writing L, we'll say this is per unit length. So when I put the value of B, I get mu naught by 4 pi into 2 I1 by R into I2 sine 90. So the force is mu naught by 4 pi 2 I1 I2 by R. This is the force which the second wire experiences due to current flowing on the first wire. We can go similarly. Now we start with the magnetic field generated by the second wire. So for magnetic field to second wire, we use the same formula. We write B2 in this case, and we say B2 is equal to mu naught by 4 pi into 2 I2 by R. This is the magnetic field at a point Q over here. Current flowing in this wire, creating magnetic field on this. Once again, when I use right hand thumb rule, I can see magnetic field is going to come out of the plane of the paper, which I can depict like a dot over here and by this particular arrow. So we have magnetic field direction once again coming out of the plane of the paper, current going like this. So angle between them is 90 degrees. Therefore, force expressed by 1 due to current in 2 is equal to mu naught by 4 pi into 2 I2 by R into I1 sine 90. Once again, we have not taken length because we are going to write this as force per unit length. So what we got? We got F12 is equal to mu naught by 4 pi 2 I1 I2 by R. So both forces are same. Now we need to talk about the direction of the force, for which we use Fleming's left hand rule. Alright, this is force, this is current BIL. Okay, or we say FBI, force, magnetic field, current. So when I look at this and I put it for here, for example, magnetic field is going inside, current is going up, therefore force, as my thumb points down, is along this side. So this is the direction of force on 2 due to 1. Using the same rule, we get force on 1 due to 2 as F12 in this direction. Therefore, what we can say or conclude is that forces are attractive. What is the condition for forces to be attractive? Current in both wires is in the same direction. From which also tells us that if current is not in the same direction, then the force between two wires will be repulsive force. All right. Now, whenever we get this question about derivation of force between two wires, we also are asked to define ampere using this particular formula. So what we do is, we say, first of all, F mu naught by 4 pi into 2 I1 I2 by R. This is what we got. Then we say if I1 is equal to I2 is equal to 1 ampere. That means 1 ampere is flowing through both the wires and the distance between them is 1 meter. Obviously, they are placed in air. Then what will I get? Value of force. Mu naught by 4 pi, we get 10 raised to minus 7. 2, current 1 is 1 ampere, current 2 is 1 ampere, distance is 1. So our answer we get here is 2 into 10 raised to minus 7 Newton per meter. Based on this, we define 1 ampere is that current which, when flowing through two parallel straight current carrying conductors placed 1 meter apart in air, the distance is 1 meter in air, results in a force of 2 into 10 raised to minus 7 Newton per meter of their length. So this is an important derivation. It may come for 3 marks along with definition of ampere. It may come for 5 marks where you define ampere and do a question based on its formula, numerical based on its formula. So 3 plus 2 kind of did. So this is an important one. It has been often asked in boards exam. Prepare yourself for it. Thank you.